So finally got around to actually bootstrapping the cluster. So if I do a kubectl get pods namespace kube system, you can see here my cluster is up and running on all 4 nodes in the cluster, the 3 workers in the master. If I do a kubectl get nodes, you can see my workers are ready. My master is not ready, only because I'm not allowing workloads to run on the master. So none of my pods for any applications are actually going to launch on the master, and that's good practice. You want to do that for security reasons. So we'll start going over the playbook now. So the playbook. So if we look over here, we're in the bootstrap cluster role, main.yaml. So I'm going to take this firewall-d part out. Turns out Kubeadm and Kubernetes, it works fine with firewall-d. I was having some weird issues, but we figured those all out. We're good to go. You can keep firewall-d on. So if I do a systemctl status firewall-d here, you can see it's running and the cluster is running. So I'm going to remove that. Bridge utils. I did install bridge utils because later on down the line, because I was destroying the cluster, the entire cluster, I had to remove the CNI interface. And there is an issue with Flannel where it doesn't remove the CNI interface sometimes. So I have to do that manually. But in order to do a brctl to delete the bridge interface, I have to install bridge utils. So I'm actually going to move this to the part where I install the prerequisites for the cluster. But here's where we get to the meat, right? So the bootstrap cluster role will initialize a cluster if you don't have one running, and if you do have one running, it will delete it and all the things involved in that cluster and do the init again. So one of the issues you run into is if you do a Kubeadm reset on the master, and you have workers joined from a previous Kubeadm init, you're going to get issues. So you have to delete all of the nodes from the cluster if you're going to relaunch the entire cluster. So we do a kubectl delete nodes, and we pass the all option. We only run that on the master, but it will delete all the nodes. And then we remove any stale IP table rules and the CNI interface. So let me just go ahead and show you something right here. So if I do a Kubeadm reset here, yes, it's going to do a bunch of stuff, right? First, it says there's no Ectd config found, assuming external Ectd, and that's true. I am using an external Ectd. So I have to manually remove the Ectd configuration if I want it gone, right? Then you see how a Kubeadm reset, it gets rid of all these directories, but then they tell you the reset process does not clean CNI configuration. Please remove that. And the reset process does not reset or clean up IP tables. So that's the reason for cleaning up IP tables. And then I've already explained, I delete CNI 0 if it's not already existing. That's why I ignore errors, because if it doesn't exist, I'll probably create some kind of conditional to check for it and only run this if it is there later on down the line. And then we open up IP tables, and this was an important step for me. Even though I was using firewall-d, I was having a lot of issues without opening up IP tables, so I just go ahead and do that. We clean up the cluster, manifests, and Ectd and CNI, right? So actually I need to change this. I was deleting the manifests before I learned that in the new version of 1.21.0, Kubeadm is actually deleting manifests for me. You see here it removes the etc Kubernetes manifest directory. It's up to me to remove Ectd because I have my own external Ectd. Because if I do a Kubeadm, if I destroy the cluster but leave the old Ectd, the old cluster information is stored in Ectd, and it can cause some issues, so we just want to clean that up. I delete the .kube directory with the old admin.conf because the cluster no longer exists. That admin.conf is no longer valid. And then I delete CNI netd, that deletes the Flannel configuration, so we don't have an old stale configuration. So in the same playbook, because this role is meant for an initial deployment of a cluster or deleting an existing cluster and redeploying a cluster, we're always checking for Etcd, right? We don't have to reinstall Etcd every time, but if it's our first run through, we need to install Etcd if we want an external Etcd. If you don't want an external Etcd, you might want to comment out all the Etcd stuff in the playbook, and then Kubeadm will actually deploy an Etcd container. So download Etcd version, easy enough. Unarchive it, again, easy enough. Move the contents to user local bin for Etcd and etcd-ctl. Make an etcd and varlib etcd directory, and this is installing Etcd from scratch. All this is, and then we need to copy our certificates, our CA and our master key and master PEM, which we will later pass all this external Etcd information into our kubeconfig. And then we need to create the systemd service for Etcd. So we have a Jinja template here with our Etcd service. And again, we're using the host name, we're passing in our certificates and our keys, defining an IP. And so obviously we have some variables in here that we need to define. I'll make sure to put that in the README. And then once we place the template, we can do a daemon reload using systemd module, and we can start and enable the Etcd service. So now Etcd is running. So if we didn't have Etcd installed, we've installed it and it's running. If we did have Etcd installed, unless we change something in the Etcd template here, if we rerun this playbook to destroy the cluster and rebuild it, Etcd shouldn't change at all. So after Etcd is installed, we are configuring the control plane and the workers, right? So we're going to do a Kubeadm reset, and we're going to pass -force so we don't have to respond to the command prompt of yes or no. And that's going to reset the Kubeadm cluster. It's going to delete all those containers, tear away some configurations. We've already gone over that. And then we need to copy our kubeconfig for initializing the cluster. Before we go over that, let me go to Kubeadm init, which is this is how we deploy Kubeadm. So we'll do a Kubeadm init -- config, which tells Kubeadm I want to use this configuration file, and then we pass a configuration file, which is the one we're using up here that we copy to the host. So that's a J2 template, and it's over here. So real quick, just going over the config real quick. So you can do a Kubernetes version latest in the config, or you can define a version. You can do just a bare bones config, so you don't need you don't need to pass extra API server configs, extra Etcd server configs, or networking configs. You don't need to pass config at all. You can do a Kubeadm. You can just do Kubeadm init, and then you can pass a pod subnet using whatever command that is for that. So if we actually go to the documentation here, and I'll put a link to this in the description. Kubeadm init, right? It takes multiple different commands. So if we look here for, let's say, you can pass all these options through the command line, or you can put them in the config, right? So if we do pod network cider, right? So if I did a pod -network -cider here, cider, and then define my subnet 10.20.30.0/24, whatever I needed it to be, it would be the same as defining pod subnet under the networking section within the configuration. So I'm going to go ahead and clear that. So what are all these extra things that I'm passing in here? Well, for API server, I'm advertising the address that the server is hosted at, which is the master. And then we have an encryption provider config. Actually, let's see, Kube API server, right? So they give you in documentation, they say what flags can you use, right? So these options, again, can be passed manually, or you can put them in the config. Putting them in the config is obviously easier. So if we look at advertise address, right, this string matches what we have over here, advertise address. And if we look at encryption provider config, right, that I have passed here, encryption provider config, that is also a valid option in the documentation, encryption provider config string. So one important thing I want to go over about the encryption config is that, let me get rid of this. You need to place the encryption config in a directory that the Kube API server will be able to reach. And what I mean by that is, if you look at the container for Kube API server, you'll have a volume section where it mounts volumes within the container to volumes on the local host. So if you place encryption config.yaml in, say, your home directory, if the Kube API server doesn't mount your home directory inside the container, it can't find it, right? So Kube API container will mount etcpki. So I just dropped the encryption config in Kube or in etcpki, and Kubernetes will know to use that encryption config. Actually, so where is that? Actually, so yeah, we'll go to secrets in that YAML, and you'll see I put the encryption config in etcpki. And this is a change from one of the other videos that I ran into while trying to do this. So let's continue. Cluster kube config, right? Because I have an external Etcd, an external meaning it's not a container pod created by when I do a Kubeadm init. It's a systemd daemon that I've installed personally. So I need to define the endpoints that are going to want to connect to Etcd, and I have to define the certificate authority and the keys and the certs. And then we have networking, which is the pod subnet. And the pod subnet, real quick, has to match the pod subnet in your Kube-Flannel right here. Because if you try to do the kubectl create-f, wherever the Flannel config is, if you use the default one from the internet, it's going to have a 244 here. So if your pod subnet and the Flannel subnet network don't match up, you're gonna have issues. You're gonna have a bad time. And then where's my cluster? Kube config. And then I have an init configuration, and this just tells, because I'm not using Docker, this just ensures that certain properties in the, so I have kubelet extra args. So when Kubeadm starts kubelet, it's going to pass these extra arguments to the kubelet service, and it's going to know to use containerd as the runtime and use systemd for the cgroup driver. And this is supposed to happen automatically, but I have run into instances where it didn't. So just to be sure, I include it here. So continue. Kubeadm reset gets rid of an old cluster if it exists. We place our config that we're going to pass to Kubeadm init. Kubeadm init, we use that config. And then when that's done running, we'll create our .kube directory wherever we need it to be, right? So I create a .kube in my K8s admin and my root, so they can both run kubectl commands. And then we copy the admin.conf that's created by Kubeadm from etc kubernetes admin.conf. If you do not copy the admin.conf, or you do not specify an environment variable for admin.conf and where it's located, kubectl will give you a could not connect to localhost port 8080 connection refused, because kubectl doesn't have the credentials to access the API. and get information about the cluster. Then we, actually what happened here? What did I do here? So we copy the admin config. On the master, we can copy the admin config because it's placed on the admin, or placed on the master. Initially, Kubeadm places it on the master. So we can just copy it around the master. I can't, however, just copy it to the workers. I need to either get it on the controller and distribute it back out to the workers, or sync the workers directories to the master in some form or fashion. So again, I'm using what I use all the time. I use the find module to find the Kubeadm config. I fetch it back to the Ansible controller, and it actually goes under files over here. And again, that's not safe. You don't want to push this to Git. Just a heads up, you might want to add that to your .git ignore. And then we distribute it to the workers. So once Kubeadm is initialized, our master's up, we can join our nodes. So I'm sure there's more elegant ways to do this, but in order to do a Kubeadm join command, you need a token. So when we get a Kubeadm init, you'll get an output that says your cluster is ready. You can join nodes using Kubeadm join with this token and this certificate authority hash, right? So here I am creating a token, right? So I'm running Kubeadm token create. So once Kubeadm has already created the master, initialize the cluster, I create a new token, and I output that to, and I print the join command. So this is all one command. Actually, let me run this real quick. I don't know if it's going to go off because I did the Kubeadm reset. Probably not, but I'll output that to join.text, and I'm going to parse join.text. I'm going to look for the fifth field within the awk output. I'm going to register it as a token variable. I'm going to create the token variable. I'm going to output the token variable to the screen just so I can see that what it is. And then I'm going to do the same thing for the hash. I'm going to awk, take the seventh field, put it into a variable, output it to the screen. So once we've created the token and hash variable, it's very important. These variables are being created on the master node, right? And when variables are created, they're stored in memory for the entire run of that playbook, but then they're deleted from memory. So these variables are only in memory on the master. So I have to find a way to get these variables to the worker nodes, right? I have to find a way to store them to use on another host. So what we do is we add the token and hash to a dummy host and pass the facts between the host. So I add a host, and the name is the IP of my master host. And I say this host has a variable of token and hash, and these are the variables. Easy enough. Ansible stores that. And then we'll skip Flannel for now. Join the nodes, right? So we take those stored variables and we can pass them into a Kubeadm join command. We use the IP address of the load balancer, which is gonna, so the Kubeadm join command is gonna hit the load balancer, and the load balancer is gonna pass it to the API server on the master. The token variable we created and the token CA cert hash we created, and the workers are all gonna join. So going back to Flannel on networking, right? So we're gonna, well, let's go to the documentation for Flannel, right? So if we go to the documentation page here for Flannel, getting started on Kubernetes, they tell you you can apply Flannel using a kubectl apply this address. So if you take this address actually and you paste it in your browser, so I'll do it real quick. It's going to bring you to the YAML file, and this is what kubectl apply is going to apply. It's going to apply everything in this file right here. You need to if you're gonna customize anything in that file, you need to copy and paste it and put it in your own file, right? So I copied and pasted it, put it in a kubeflannel.j2. I changed the network, the pod CIDR, to match my pod CIDR that I defined in my cluster kube config, right? So 240/16, 240/16, because if those don't match, you're gonna have issues. And then I distribute it to the master. And then we just do a kubectl apply wherever I put that kubeflannel.yaml on the master. And then just the way the playbook is written, the fact that it destroys the entire cluster, it does so much undoing. Containerd needs to be restarted. So I wait a minute after the Kubeadm init and join are all done. We wait 1 minute for all the containers to come up, and then we restart containerd, and then everything will be happy. It'll be running. Because if I didn't restart containerd, I was hitting an issue where the core DNS pods were in a pending state forever because the CNI interface wasn't being created. But with a restart of containerd, the CNI interface did get created. So now that I've gone over the playbook here and how it's laid out, let's rerun it, shall we? So I'm going to do just the Kubeadm init part because we know everything else works. And it's going to run through it. And it's going to tear down the cluster, delete Ectd. Not entirely, it's just going to delete the contents of the Ectd key value store. And we should be left at the end with a fully working cluster. All right, so playbook is finished running. So now if we go ahead and go back over to our master node real quick, we do a kubectl -n kube-system. What am I doing? Kubectl get pods namespace kube-system wide. We can see everything's running. We got 0 restarts, and even our core DNS is running. So feel free to look at the links in the description for some of the Kubeadm documentation. I was using the Flannel documentation, the link to the GitHub repo I'm storing these playbooks in. I'm thinking next I might do a video on using containerd versus Docker and how those command lines differ. You know, you've got Docker PS, you've got CRI/CTL for using containerd. You know, they differ a little, the setup differs a little. I'm also thinking about doing a video on deploying the Kubernetes dashboard. So that might be easy. We can do something like that. And then I really want to get into a lot of CI/CD pipelines, Jenkins, GitLab, security for the Kubernetes cluster, stuff like that. So I'll see you guys in the next video.